In 8.4, we'll look at binary numbers. Binary numbers are used primarily in computer programming, but they're also used in manufacturing settings with programming measurement tools. These notes are found on page 56 of your workbook, and this is our 8.4, like I said. So binary numbers use powers of 2 for place values. Because it's binary, it's only bi means 2, so that's why we have powers of 2. But it also means we only have 2 numbers. We only use 0 and 1 to write our numbers. So our first number over here would be 2 to the power of 0, and then 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6. Now 2 to the power of 0 would be 1. 2 to the first power is 2. 2 to the second power means 2 times 2, which is 4. 2 to the third power means 2 times 2 times 2, which is 8. 2 to the fourth power is 16. So we're just multiplying by 2 every time we go over. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. So to write a number, base 10 number, as a binary number, we'll put a 1 underneath the biggest number in the table that's still smaller than our number. We'll subtract that from the base number, the base 10 number, and we'll keep repeating that until a number is left. So it's harder to explain it than it is to do it. So here, first of all, let's fill in the top row with our numbers. We have to start with a 1, and then we multiply by 2 every time. So 2, 4, 8, 16, 32, 64. So we have 40 as our number. We look for the number that's the biggest number we can get that's still smaller than 40, and that's this 32. So we'll put a 1 underneath the 32. And then we're going to subtract 32 off of it, and we have 8 left. So then we look for the biggest number that we can get to 8 without going over, and that's 8, right? And we subtract 8, and there's nothing left. So that means we're finished. Now all the other spots we fill in with zeros. And we normally, so this is how we write our numbers: 0, 1, 0, 1, 0, 0, 0. We don't put any commas in. We don't normally write a 0 at the very beginning. So we'd have this is the binary number for 40. Let's do it again. We'll again fill in our numbers here. So this time we're starting with 25. So what's the closest number we can get to without going over 25? The biggest number, and that's 16. So we'll put a 1 under 16. That means we've used 16 of these numbers, which means we have 9 left. Well, the next closest we can get to 9 is 8. So we'll put a 1 under the 8. I'm going to subtract 8, and I have 1 left. The next closest I can get to 1 is 1. So we'll fill in the empty spots with zeros. We don't worry about the numbers that were bigger than our number to begin with. And so we'd have 1, 1, 0, 0, 1. So here you want to write 15. So again, I would start with my numbers to guide me. I'd start with 1, and then 2, and then 4, and then 8. And then the next number is 16. 16 is already too big, so I don't need to worry about that. So that's my little table. 8 gets me as close to 15 as I can without going over. So 15 minus 8 is 7. And then I can use a 4. 7 minus 4 is 3. So then I'm going to use a 2. 3 minus 2 is 1. That means I still need the 1. So 15 is 1, 1, 1, 1. So to go the other direction, to write a number in base 10, if we're given binary, we fill in the 1s and 0s, and then we add them up, add up the numbers that we have. So let me show you what I mean. Again, we start by filling in our boxes on the top. 4, 8, 16, 32, 64. Now we're going to write this number in the boxes below. When we do it, we need to make sure that we have it lined up on the right side. So we have 5 numbers there, which means we need to have 5 boxes. So we'd have 1, 1, 0, 1, 1. Okay? So this number 1 is telling us that we have 16. This one is telling us that we have 8. This 0 is saying that we don't have a 4. The 1 is telling us that we have a 2. And the 1 is telling us that we have a 1. In binary, it's like a yes or no. It's just 2 options. 1 means that we have that number. Yes, we have that number. And 0 means no, we don't have that number. So we add up the numbers that we have. 16 plus 8 plus 2 plus 1. We get 27 as our number. So we'll do the same thing here. We'll start with our numbers on top. You should get those memorized pretty quickly if you write them out every time. We can see that we have 1, 2, 3, 4, 5, 6, 7 numbers. And that means we're going to use all of our boxes. So we'll fill in the numbers underneath. By the way, it doesn't stop at 64. The next box would be 64 times 2, which is 128. The next box would be 128 times 2, which is 256, and it keeps going. So let's go back to this problem here. Here this tells us that we're going to use 64. We're not going to use 32 because of the 0. We're going to use 16. We're not going to use 8 because of the 0. We're going to use 4. We're going to use 2, but we don't want the 1 because of the 0. So if we add those up, we get 86 as our base 10 number. We'll do one more example. Again, we have 1, 2, 4, 8, 16, 32, 64. We have 4 numbers here, so we just want those numbers in those last 4 boxes. That means we don't need these. This tells me here I have an 8. I don't have a 4 because of the 0. I have a 2, and I have a 1. So if I add those together, I get 11.